we're doing trig identities, and just something to look at is the Pythagorean identities. Really, of these 9, if you just remember this first one here, you can figure out any of the other ones. Because like if I were to divide everything by sine squared of theta, for example, sine squared and sine squared and sine squared, well, this will just become 1. Sine squared over, or cosine over sine is cotangent squared, and 1 over sine squared would be cosecant squared of theta. Well, guess what? That is, where is it? This one right there. And you can get to any of the other ones just by moving from one side to the other. So let's just do examples. After we say here, this is what we need to do. The rule is you want to work on the more complex slide first, because you can only work on one side of the equal sign. You can't try to solve the equation, just simplify one side. So in this one, the more complex side obviously is on the left. I want to try to change things to be sine and cosine. So this first one's cosine will stay the same. Secant, though, can be rewritten as 1 over cosine of theta. Well, if I have cosine divided by cosine, that's just 1. Well, guess what? That's what we wanted to get it to, was 1. So we're done already. Another one, a little bit more complex here. In this one, again, the more complex side on the left, I'm going to FOIL. So 1 minus cosine theta plus cosine theta minus cosine squared of theta. If I can simplify that, well, yeah, because those two go away. So I have 1 minus cosine squared of theta. And when I have something like this, something squared, a trig function squared with the 1, let's look for a Pythagorean identity. Well, yes, it is sine squared of theta, and that's what we wanted to get. So again, we are done. Our next example, there's actually 2 different ways you can solve this problem. The first one I'm going to say is, well, up here at the top, I can use Pythagorean identities. That's tangent squared, and we spell secant squared on the bottom of theta. What I'm going to say now is, well, secant squared, or just secant, is the reciprocal of cosine. So if secant's on the bottom, cosine will then become on the top. So tangent squared theta times this would then be cosine squared theta. Let's turn everything now into sine and cosine. Tangent is sine over cosine. So it's sine squared and cosine squared. And then we were multiplying still by cosine squared. Well, guess what? The cosine squareds go away. I'm left with sine squared of theta, which is, again, what I wanted from there. Now, the other way that I could have solved this problem was I could have said, well, if I have these 2 terms in the numerator, only 1 term in the denominator, it's kind of like doing the anti of combining like terms or combining fractions. I can split it up, secant squared on the top with secant squared on the bottom, and then the minus 1 with secant squared on the bottom. The secant squared, that's just going to be 1. And again, we said secant, 1 over secant was the same as cosine, so it would be minus cosine squared of theta. And again, a Pythagorean idea here, so I should get sine squared of theta. And on your homework, the first problem we kind of talked through a little bit. I'm going to start with the left-hand side, a little more complex, just because I like getting things into terms of sine and cosine, which it already is on the right. So it will be sine of theta over cosine of theta for the left hand, or from the tangent, and then cotangent is cosine theta over sine of theta. From here, let's see, I have 2 fractions. I want to eventually get into one big fraction. So I need to make a common denominator. I would multiply these 2 together to get that. Cosine theta times sine of theta. To get the numerators, I need to multiply cosine by sine to get my new denominator. So I'll do the same at the top. Which means sine times sine is sine squared. Same over here. Sine needs to be multiplied by cosine, so I'll do the same at the top. Cosine squared of theta. And then this numerator, quite easily, just is 1 based on our identity. So 1 over the same denominator. Cosine theta, sine theta. And that's, again, what we wanted to get.